This is Chapter 5 Loops, Programming Exercise 9, Find the two highest scores. Write a program that prompts the user to enter number of students and each student's name and score. And finally, display the students with the highest score and the student with the second highest score. Use the next method in the scanner class to read a name rather than using the next line method. So why it asks us to use the next instead of the next line? Well, let's find out what's the difference. So let's imagine, right, we ask the user, hey, enter the student's name and the score. So that's one line, that's one string onto the console. Now, when we have next line, it'll read the entire line, Kevin space 80, and if that's the entire line, it'll grab that and it'll store it into whatever variable that you have using to store that. So it'll store this whole thing, Kevin 80. Now, we don't want that. We want to grab a hold of the user's name and then grab a hold of the user's score in two separate variables, a string name and maybe a int score. Now, we could do that by using the next method. And the next method takes a look at the string, but it doesn't grab the whole thing. It just grabs the first word and stores it into your variable, right? It goes up to space and say, okay, so that's where the word ends. I'm just gonna grab that, I'm gonna stop, and I'm gonna store it, or use it, or do whatever you need to it. And then when you call the next method again, it'll look at the space. Okay, this is where I stop. I'm gonna start from here and go all the way to the next space. And this time it'll grab the 80 and it'll store it to wherever you need it. Same thing, it'll grab, if you use the next, grab the Adrian, stop there, use next again, it'll grab 50. That way you could get a name and a score. Instead of a next line, it'll grab the whole thing, Adrian 50 or Daniel 100, right? So let's take a look at that and let's try to tackle that in our exercise. Now, first thing I want to do is, of course, be able to ask the user to enter the number of students. That will be our first, so we know how many times to loop. We'll create a final byte number of students. Right, so final is therefore so the user can change the number of students afterward. Not that I don't think the user will need to, but we'll just have that there because it seems useful, right? And all right, so since it's final, we will uppercase the variable name. All right, so for byte I 0, as I is less than number of students, I plus plus. All right, so in here, that's where we're going to find out the student's name and score. We're going to ask the user, system.out.print, enter the student's name and score. Okay, now where are we going to store it? Well, I would like to store it inside a string builder. Now, the reason for string builder and not string or string buffer is because string is immutable. And since I'm going to be expecting many students' name to be entered, that the string builder class will allow me to constantly change the name. While string, since it's immutable, if I store a name and then store a new name, it's going to keep all the old names in a place called the string pool, which is going to take up extra memory than needed. So that's why I'll use the string builder. Now, what's the difference between string buffer and builder? Well, the similarity is that they're both mutable. So that means that you can make any changes to the string after it has been set. But the only main difference is that one is faster than the other. The builder is faster than buffer, and that's because buffer is thread safe. But don't worry about thread safety yet. We'll tackle that in a future chapter. So for now, I'm using string builder because it is mutable. I can make change to it, and it's faster than string buffer. So string builder SB, let's call it student name 1, because we're going to have 2 students actually, comma, with the comma, SB student name 2. All right, and I'm also going to have the score. Student score 1, comma, student score 2. This is for what we're going to see right here. So first thing I'm going to have is SB student name. Well, actually, before I do that, I'm going to actually create a temp. Should I create a temp? I guess I don't really need to create a temp. Yeah, I'll create a temp. It'll definitely be helpful. String builder equals SB temp name, and I'll create a score right here. Student temp score. Okay. All right, so SB student name is going to store the student's name, so it'll be input.next method. And I haven't initialized it yet, so this variable right here is a string builder object. So I'm gonna have to say new string builder and store this into this new string builder object. So now I'll convert this string into a string builder. All right, now for my temp score. Now, the thing is, input.next will read the next item as a string. Even if I enter it as an integer, it'll still read as a string. So I have to be able to convert it. Now to convert it, I have the byte class, right? Now the byte class has a parse byte method. So it reads in this next method here, which will grab the supposedly score, but read as a string, parse the string and turn it into a byte. So let's get a visual on that so we understand what all of that means, right? So we have an idea. So for now, let's just say one student, enter the student's name and the score. So this will be the student's name and the score, and it'll store this into SB temp name and this into temp score. But that's not so helpful, right? Actually, I should print it out. So we'll have name is SB temp name plus new line score temp score. Okay. So let's run that again. Enter number of students. All right, so here we go. So that's exactly what we want to do, right? We ask the user to enter the name and the score, right? The name and the score in one line, and we use the input.next, which the first time it's used, it will read the first part of the string. Second time it's called, it will read the second part of the string, and it'll store this string here into this SB temp name, and then store as a string builder object. And this score right here will be stored, is being grabbed as a string because of input.next is grabbing as a string, but it's being parsed into a byte, right? A byte data type. And that's why we see 70. All right, now it's being stored into this byte. And then we display all of that. All right. Now for the tough part of this exercise, which is to basically store the top two students. All right. Now what I'm going to do is actually set this to equal to -100. And the reason for that is because I'm going to have to do several checks. So what I'm going to do is I'm going to do a temp score. Hey, if temp score is larger than student 2's score, well, what I'm going to do is basically now grab student 2 and it's going to store the new temp score. Okay, But I also want to know the student's name. So I'm going to grab student name 2, and it's going to equal the SB temp name. All right. And now, because of that, I can't just simply say this, can I, right? Oh, well, of course I can, because they're both string builder data type. Before I can't is because one was read as a string and the other was a string builder. SB temp name is a string builder, and so is SB student name. That's why I have no error. So now I'm storing this into here. All right. Okay. Now I also have to do a check in here. So now I have an inner if right here that checks, hey, is student score 2, is their score greater than student score 1? Well, if it is, then I'm going to do a whole lot more reversing around here. Now I want to make a backup of student score 1 first. So I'm going to store that backup, whatever it may be, right? Into this SB temp name right here. So actually, let me store the score first. So I'll just store the score first, and then I will store the name. All right, and the name is just going to be where's the right here. Okay. All right, I did. SB student name. Oh, it has not been initialized. Well, of course. So what I could do is equals new string builder. There we go. Initialize it, because right now it's not been initialized. Nothing has been set to it, so it's just some garbage data type. So we don't want if for the first time it runs, it'll hold some garbage data type. For the next time it runs, it'll hold on to a score. So that's why we got that error. All right, so just in case there is some score in here, we want to back it up. That way, we could use it for later. Now, student 1 score is going to hold the highest score and the name of that student. Okay. Now finally, since student 1 was previously holding the highest score, but you have set it now to the new highest score, and that student's name, you want to back up the previous highest score, just in case this student is actually the number 2 student. So since we back it up here, which is perfect, we could just do student score 2 equals to the temporary score, which holds on to the temporary score from before. And student name now equals the previous one. All right, so this might all be a bit confusing. Let me print it out and let's get a visualization on it. Student 1, I'll just say top scoring student is, and that will of course be student name 1 with the score plus and student score 1 plus. Okay, paste that. Second highest scoring student is, and of course that'll be 2, 2. Oh, that's not been initialized, so let's just initialize it just in case. Right, so the reason for that is if this for loop never gets entered, if this if statement never gets entered, then it'll never get initialized. All right, so let's give that a try. All right, so let's say we have 3 students. First student with a 70, second student with a 50, third student with 100. Ooh, can't even see it. All right, let's do that again. 3, 6. All right, there we go. Now the top student is Daniel with the score of 99. Second highest scoring student is Daniel with the score of 76. So something went wrong where it did not store the name properly. So let me take a look at what I did. All right, so, okay, that's because I made a mistake right here. The temp is supposed to hold the second student's highest, the second scoring student, and that's why I made a backup right there. All right, so let's try that again. 3, A1, D5. All right. Top scoring student is D with score 5, and second highest scoring student is K with score 3. All right, so that works exactly how we wanted it. We have basically grab the student with the highest score and then the student with the second highest score, and we display all of that. All right, so let's understand how the code works. So what we have here is first asking the user, hey, how many students do you have? And that's stored into this variable right here, which is numbers of students. Next, we create the string builder. String builder is like the string class, except that it is mutable, which means that when you set a new value to it, for example, we set a new name to it, each time we set a new name to it, it will take hold of that new name and it will store it, and it won't take up any extra space in memory. Unlike the string builder, if you create a new name and then you change the name, it'll hold on to that name in the string pool, assuming that you're going to use that name again. So that could take up quite a bit of memory if you have a lot of names to go through and you're only using a few of it. And that's why we use the string builder. For the byte, so the byte can only hold a maximum size of I believe 126 or 127, right? Up to 127. So assuming that our score will never go past 100, then there's no need to use a variable of or a data type that's that large. And that's why we're using bytes, which just takes up 1 bit of data, of memory, all right? And by default, we set it to -100. So we also have to assume, so we're assuming a lot of stuff here, right? We're assuming that, assuming score will never go past 100 and score will not be negative, okay? Where the lowest score you could possibly get is 0. So that's why we set it to -100, because that will be useful to us inside this for loop. So we have for byte I equals 0, it goes up to the number of students that has been set, which has been set to final, which can't be changed afterward. And inside this for loop, so if you enter 5 students, it will run 5 times. So you could get both the student's name and the score of all 5 students. Once again, we have another string builder data type here, which is our temporary holder, right? It's a temporary name holder. We're only going to grab the name temporarily, and we don't need it afterward. So for example, this is why it's created inside a for loop. And once the for loop ends, once we're out of this for loop, out of this this trace, this scope, right? Out of this scope, this string builder object and this reference will be deleted. It will be gone. It will be removed by Java's garbage collector, and that will allow us to maintain more memory. All right. So it's created inside the for loop. so is this byte, this temp score variable of byte type is also creating this for loop, because that's the only time we'll ever need it. We won't be needing it outside of for loop. All right. Now within the for loop, we're going to ask the user, please enter the student's name and score however many times you need, right? So that will be asked from the beginning. For each time we ask the user to enter the student's name and the score. That way, we could grab a hold of the student's name, all right? Grab hold of the student's name. Let me see if I can pull this up. Where did it go? Where did it go? Let me see if I could run this. There we go. All right. So that way, where was I? That way, when we enter something like this right here, it'll grab a hold of the name and then the score using the next method. If we were to use the next line method, it'll grab the whole thing and store it onto this variable, and it's not going to grab the score into this variable. Instead, you're going to get some kind of issue, right? Because now it's expecting some kind of variable. So that means it's not going to continue the for loop until you enter a variable that's expecting, or the score that's expecting, and then it's going to store it in here. So that's going to create a whole bunch of other mess. So you got to make sure you know which one you're using and how you're using it, the next method or next line method. If you use the next line method, then you're going to have to just parse it, right? Parse the number out of it. Now, after we got hold of the name and the score, we want to make sure to keep track of the number 1 student and the number 2 student. All right, so how does it keep track? Well, what we have here, since we have a temp name and a temp score, we're constantly checking this temp name and temp score with top student number 2. So if top student number 2 turns out to be a student with a less score than the temp student, then it'll swap it. It'll swap the score. It'll store it. Actually, it won't swap. It'll just store the new number 2 student. And then it'll check. Hey, is the new number 2 student better than the current number 1 student? If it's not, then it'll go out of the scope and continue on to the next loop, onto the next iteration. If it is, then we'll do a giant swap. We're going to remember the number 1 student, hold on to it in our temp right here. Then we're going to store the top student, which is currently being stored in number 2 because of this right here, right? And then store into the now number 1. And then now number 2, which holds on to number 1, will now grab the new temp, the temp data which we previously got from student number 1. All right, so hopefully that makes sense. Now let me see if I could do a quick visual right here. All right, so let's say we got Kevin 60. Kevin 60 will now become student number 1. All right. And then we go on to the next score. Actually, Kevin 60, because of this, Kevin 60 will become student number 1 and student number 2. And then we see Daniel. Daniel is not better. The score is not better than 60, so skip it. Then we see Aderna. Aderna has 80 and is actually better than Kevin S2. So now it's save Aderna to Kevin S2. And we see that Aderna is actually better than student 1. So now, instead of Kevin being the number 1 student, we have Aderna being the number 1 student. But we also want to keep track of the number 2 student, so we just swap it. We just have a temp now holds on to the data of Kevin, and then Aderna now moves to takes over Kevin's spot, and then Kevin goes to number 2 spot. So that's all that is happening right here. All right, so hopefully that makes more sense. And finally, after we're done looping through all that, we display it. We say Aderna has a score of 80 while Kevin has a score of 60. So So this is your number 1 and number 2 student.